Okay, kids, how are you doing? I am preparing this video for you to understand how to solve this kind of exercises with some percentages which you have to take into account. Okay, in the first place, for today's exercise, we've got that there's some sodium reacting, in this case with orthoboric acid, and determine the grams of salts you obtain. So basically, in the first place, what you need to take into account is that, well, first of all, let's read what you have, right? It says grams of sodium. There's some sodium reacting with orthoboric acid. So yes, there's 14 grams of 85% react with. Determine the grams of salt you obtain. That means in the other side of the equation, you're going to obtain the salt. That's what I need you to read. Always trying to enclose the variables in bold, which is the element that are going to react, and the elements you're going to produce, or the compounds you're going to produce. That's very important in the first place. So let's proceed to work that. Let's try to create a reaction first. So if you write that, we're going to see that there's some sodium, right? It's reactant with some orthoboric acid. If you don't know what orthoboric acid says, or I advise you to ask your teacher or go online for seeing what's the formula for that one. So if you go online, you're going to find out there's orthoboric acid is H3BO3. So yes, yeah, you have to ask that to your teacher definitely. And if you don't remember, or if you have mastered the art of practicing with chemical nomenclature, then you will know that orthoboric acid is the only valence number is 3 with 3 molecules of water. That will be then. Anyway, and in the product, it says that you're going to have a salt. It says you create the salt. Well, so let's try to think about that. I need you to remember something about how to make the salt. The salt is a chemical reaction between a metal and any non-metal, or in this case, since it is an oxalic acid. I need you to picture this into your mind. Think about that. Right, any acid is going to be divided or separated, like I am doing in this moment, with this, the radical and the hydrogen, because it is an acid. So whatever number the hydrogen has is going to become the oxidation number for the radicals. In this case, BO3 is 3 minus because there are 3 hydrogens into the acid. And also you need to remember the sodium is 1 positive, right? Sodium is 1 positive because it has 1 electron in the last level of energy. If it meets this positive with this negative, which is what normally is going to happen because unlike charges attract, so this sodium is going to unite this one. I need you to recall this example for like going to a party. That's because hydrogen is also 1 positive. So like the 2 positive theirs are fighting for being with BO3, which is negative, like boys and ladies in a party. So the hydrogen went with the BO3 to a party, positive and negative, but then the sodium is kind of stronger because it's more electropositive according to the periodic table. So it's going to displace the hydrogen for dancing with the BO3. See what I mean? And definitely what's going to happen is this amazing thing in the lower case. So we're going to put that the sodium reacts with the BO3. And if you think about, or if you recall what it said regarding charges, we know the BO3 is 3 minus. So it's going to happen this great thing about exchange of couples, which in previous classes, I told you how to pass this by the Cruise and cross process. This 3 goes there, this 1 goes there, and you create this amazing formula. It's going to be called sodium with 3 and the BO3 with 1. So you just created the formula for the salt we were looking for, because it is a salt, because you have the metal part and the non-metal there also, but as a radical. So this is sodium orthoborate. If you think about that, so this is the salt we are looking for. We put it there. And remember what I said about the party and stuff that, so if you think about the party, so also remember that the sodium displaced the hydrogen, so it's going to occupy that space. Hydrogen is going to be released in the form of gas, right? It goes there, yes, exactly, yeah. There's no more couples for dancing, hydrogen remains alone, it goes as a gas and stuff there. Very good. So this is basically what's happening in the reaction. It says sodium reacts with the boric acid, it has created a salt, but also the hydrogen is released. Basically, you know this because you know chemistry. Definitely after that, what you will have to do is now balancing this equation for respecting the law of conservation of matter. So if you do so, let's balance this equation. I'm going to use a red color for doing so. Let's use some specific regarding the gases. We balance the gases first in this type of reaction. So we have this, I have 3 hydrogens, 2 hydrogens in both sides. I need to balance them. I'm going to put a 3 because 3 times 2 is 6. I have 6 moles of gas there. And then you put it here at 2, so it's 2 times 3, 6 oxygens, it's balanced. Now, the 2 multiplies everything inside, the radical, the BO3 times 2 is 2 times BO3. So I need to put that also in here, 2 times BO3. But that creates a new problem. So 2 times 3 is 6 sodium, so I will need to put in here 6 sodiums, and now it's balanced, right? And now, let's get back to the reading. It says, if 14 grams of sodium, so I am going to enclose that with the green one, 14 grams of sodium react with toporic acid, determine the grams of salt you obtain. This is the salt you obtained. So they are asking you to move from the sodium to the salt, okay? That's what they wanted to have in mind. And what is the meaning for this? Let's see. It says 14 grams of sodium, which they're giving you the amount, so that's why I enclose sodium. Determine the grams of salt. So I'm moving from sodium to the salt. So what I need you to take into account is the following. Now it says this, 85%. Okay, at 85% means purity. It's like, I am going to make a small drawing. Sorry for my drawings if it is not that accurate. But let's see, this is a bottle of sodium, right? Let's say it's a container for sodium. In the label you read, oh, that's sodium, but sodium at 85%. What is the meaning for that at 85%? You find it in the label. That not all of the sodium is sodium. You see, that means it's not pure. It means like for every 100 grams of sodium, just 85 grams are pure sodium, and the rest maybe could be some impurities and whatever it is. Sometimes it's only like with gold and silver and stuff like that, other kind of materials there, right? Enclosed, or some which are not in this case for sodium. Let's perform that calculation then. If that is correct, then let's pass. Then that means, Mr. Victor, I do not have 14 grams of sodium at all. Of course not. You have less. So we need to transform that, because if the 100% is 14 grams, sorry, so the 85% would be less, definitely. If you understand that part, let's try to convert and perform this conversion, and let's see. Okay, so 85%, and we open the conversion factor. Let's open our conversion factor because it works. Let's use a small line, and there. Let's pass it. I know, right? There are 14 grams of sodium in 100 grams of sample, because your total sample is 14 grams. It says at 85%. You do the conversion, right? And you put the equals there, and you're going to have that something really cool, and it's going to be right. Oh God, it's going to be like you multiply the 85 times 14. You insert that value into the calculator. It's going to be 11.9 grams of sodium. This is the value you need for working. This is the real sodium you've got. And with that one, you move in the equation from sodium to the salt. So let's get started. We enclose that. I am going to put a line there so you do not get confused about that. I am going to get started with this value, right? There, let's proceed. We move there, 11.9 grams. And I open the conversion factor there. I do this, and then I put 1 mole of sodium, right? I pass it to moles because my chemical equations in terms of moles. 1 mole of sodium is 23 grams of sodium, right? Great. And after that, I put that there. So on. We have it now kind of correct. We have passed from moles to grams. Sorry, from grams to moles, because my equation is in terms of moles. I didn't want moles of sodium. I'm just passing to moles of sodium because I am going to use those moles of sodium for my reaction. So let's perform the next conversion in the same part. Now, also it says at the same time, let's use the black color, that in the lowercase for canceling up, that there are 6 moles, that with 6 moles of sodium, I obtain, this comes from a chemical equation, I obtain 2 moles of the salt, right? 2 moles of sodium, 3 BO3. Yes, you just complete that value there, right? And then you close the conversion factor, and I have passed that one, so it makes sense. So 6 moles, and yeah. So also I cancel out the moles of sodium because I passed the moles of sodium to moles of sodium or Toporic. But also, if you open another conversion factor, you know that, right? You work that, we need to pass those moles. We're kind of close to the answer because we have everything transformed into moles of the salt, but we want in grams. So the same thing, you put in lowercase 1 mole of the salt, which is this compound. I'm just going to copy so I don't have to retake it again. Retype it again. Bing. 1 mole of sodium BO3, right? Is what? How many grams? If you add those values into the periodic table, 3 times 23 grams of sodium plus the 1,4 boron, that's 11, plus 3 times 16 from oxygen is going to give you specifically something like 128 grams of the salt, right? And if you put this there, 100 grams of this for every mole, you just insert those values into the calculator, and then at the end, you're going to have your answer, right? You cancel this, the moles of the salt, 1 mole of the salt has those grams of the salt, and at the end it's going to give you some sort of, let's put the final answer, 22.075 grams of the salt. And that will make it. So I hope you got this part. You multiplied all of the upper parts, divided to the multiplication of the lower parts. Remember to enclose everything into parentheses before dividing, and that would make it. So basically this reasoning, guys, is the one you're going to follow for understanding this kind of basic stoichiometry. It's really simple and stuff. I hope this helped you out. Remember to subscribe whenever you want to, and click and like and whatever it is on a comment, leave some comments and whatever it is. So I appreciate you guys. Thanks for watching this video. Cool. So heavy metal rules, rock and roll and stuff like that, and that will make it.